In this video, we're going to apply integration by parts to a basic integral to see how we select our u, our dv, and how the pieces play out. So, here's our integral. We want to do the antiderivative of x sine of x dx. And when we use integration by parts, it's going to come into this form. And what we choose is we choose our u and we choose our dv. Now when we choose these, they must be all the pieces of our current integrand. You could pull out a constant if you like. So when I go to choose my u, then I'm going to calculate my du. In general, I'd like my du to get easier. So I want my u typically to be something that when I take its derivative, it gets a little simpler. That won't always be the case, but that's kind of a general rule of thumb. So I know that the derivative of x is 1, so I'm going to choose that to be my u. If that's all I'm choosing to be my u, then my dv is already chosen for me. It's what's left. Sine of x dx. Now for my dv, kind of a similar type of thinking, because I'm going to use that to calculate my v, I want it to be something that doesn't get more difficult when I take an antiderivative. So the antiderivative of sine is just negative cosine of x, and that's not really much more difficult than where I was before. My du is the derivative of u with respect to x, so that's going to be 1 dx, or you could just write dx. This is the biggest piece. If you can choose u and dv correctly, you know what you're doing next. You're putting it into this form here. So let's put it together. uv, so I'm going to have x times negative cosine x minus the integral of v, which is negative cosine x, du. And I'm just going to write dx instead of 1 dx. Now, one of the big things with integration by parts is your bookkeeping. So you want to make sure you always keep track of your signs. There will be times where you have to use integration by parts more than once, and as you can imagine, if you don't keep track of your signs, you can mess up your whole problem. So I have a negative here, so I'm going to rewrite that as negative x cosine of x. I'm going to combine those two negatives here and turn that into plus the integral of cosine of x dx. So this antiderivative still needs to be taken. Now this is where you'll know if you need to use some other method. You may need to use u substitution to do this antiderivative, or you may need to use integration by parts, or you may need to use one of the methods we're going to learn, such as trig substitution or partial fraction decomposition. So we're going to go to the next line. We have a basic one here, so we're not in too bad a shape. So minus x cosine of x. That's already done. Notice it's no longer behind an integral sign. This is done. This is going to be in our final answer from here on out. Plus the antiderivative of cosine x is sine x. And now we were dealing with an indefinite integral. There were no limits, so plus c. So there's our general antiderivative using integration by parts. Again, the most important part is choosing the u and dv, and as I mentioned before, notice the u and dv, they have to take up the entire integrand, so it's a little different than u substitution.